guys. This is our agenda today. All right, so we're gonna go over the the problem we did the other day, which is this one. So reversing a list. What is the input? The list, right? So that's a list. So input list, I would say, and the output should be the reverse list, right? So, and what are there any restrictions?
Don't use the reverse function.
Yeah. So basically, can't use the slicing or the reverse function, right? I think it's reversed. I think it should be corrected as reversed. Um, Reversed method. So that's a built-in function that the take a sequence and return a reverse list. So if you pass a list, it will return a reverse list. Okay. So slicing is basically out of focus of this class. It's some of you guys probably know it. It's something called reverse slice. If you get a reverse slice, then it's actually going to reverse. Okay. So I'll probably show it to you at the end. Okay. All right. So let's do some understand over here. Okay. So all right. So let's say input list equals like I'm gonna take some random numbers like 4, 6, 8, 10. Okay, it still increases, but not one by one. Okay, so basically, I should get right this right. So 10, 8, 6, and 4. Right, that's the reverse. Right. Okay. So there are several ways of doing this manually. Right. What is the easiest to do?
Um, Make a second list.
Yeah,
Go from the back and then just put it
and put it, yeah.
Yeah.
So basically, so create a new list and append from the back of the original list. Okay, so let's try to do the basically what we are doing is we start off this and then so we start off this one and append, right? So take out the last one and append, right? So so basically I'm going to write like a the iteration number, right? So iteration 0, right? So going to be like this 10. Okay, and then iteration 1 is going to be right right going to be 8. Okay, so basically if you want you can say append 0 sorry this is which one? Minus 1th, right? So minus 1 minus 1 minus 1 element, right? So and then iteration 2, right? So append minus 2 element. So this should be iteration 1, sorry, minus 2 element. Okay, all right, and then I'm gonna copy paste. So iteration 2, right? So we'll get this 6. So append minus 3 element. Okay, and the last one iteration 3, oops, we should get, so 6 and then 4, right? So append minus 4 element. Okay. All right. So yeah, I think so. If I change this to iteration 1 and 4, let me do that. So I will have a good pattern. So right. Okay. So iterate. So basically, if I do then iteration I, right? So in this kind of question, try to find a you know pattern between your iteration number to the things that to the element that you are going to access and do things. Okay, so that means you need to find a general term. So in this case, let's say iteration I, and it should be basically append. So I'm going to remove this because we are general now. So append minus I element, right? Yep. Yep.
Minus I element minus one.
Let's see.
Because it's the zero iteration.
So I actually changed the iteration from earlier I had was 0, now I changed it to 1, starting from 1, because this looks like a range based for loop, so I can always adjust that, right? So this is append minus I element, right? So this is the general term, okay? And then from 1 to 4, basically we can simply use a range from 1 to the length plus 1, right? Yeah, because ranges are exclusive, right? So so basically, yeah, so this is the structure. When we can basically find the pattern. The pattern is basically we need to append the minus ith element uh, to the new list. Okay. Okay. So what are matches for this then? Do we have a we don't have a perfect match, right? um, did we do any list problems earlier? We did one, I think. No.
We did the address problem.
Yeah, that's the only one, right?
Yeah.
So I think we can find matches like conceptually, right? The range based for loop is one. Okay, so range based for loops, and also there was one actually. Oh, list indexes. Okay. Okay. All right. So let's write our plan. So step 1, the input. So we're going to input list. Step 2 should be what?
Create a copy or create a new list.
Yeah, we need to create it. So initialize the output list, right? The out list. Okay. And 3, now the for loop, right? So for indexes I from 1 to 4. Oh, well, not 4, length, right? Length of this input list, right? All right, so we're gonna basically to 3.1 append, right? Append the element minus I, right? Yeah, minus I ith ith to the out list. So why appending? Because appending happened back the back of the list, right? Okay. And what's the last step? Return the list, right? Right. So you have to return the list, return out list. Okay. All right. So let's implement this one. So def reverse list. Okay. And then the out input list, the input parameter. Okay. And the doc string is returns a reverse list of input list. Okay. All right. So let's initialize out list equals this, and then all right. So we're gonna append. So it's a for loop for right I in range a range is actually from 1 to length plus 1, right? Oh, we need to find the length, right? So I can do it over here. I think I can actually yeah, I can call length function, but I think so when Python create a sequence, it's actually stores the length alongside. So it's actually in the it doesn't actually go one by one and count every time we call length. So it's a strategic way. So you don't length is a frequently demanding thing, right? So better store it alongside rather than calculating every time, right? But still it's a function, right? So rather than calling every time at the header of the for loop, we can actually call it at one point and create a variable. So that might save time a little bit. Okay, so length equals len and then input list. So length plus 1, and then basically we're going to do this, right? So append, so out list dot append and append what? The elements minus I. So sorry, minus ith index of input list, right? So minus I. Okay. All right. In the end, we're gonna return the out list. Okay. So let's give this a try. So so we're gonna print. All right. So let's see. What's the syntax error? Oh, I think I need to change this. Oh, did yeah change, right? It's reverse, right? Okay. So this is the simplest. Okay, but there are ways to improve. So what are the ways to improve the speed of this? These are classic, actually classic evaluate step, guys. Okay, so this one goes through entire list, right? So can we save time? Can we do better in terms of memory and speed, storage and speed? And if so, how? Yes.
through calculus.
And how do we do that?
If you compare, like if you swap the first
Yeah.
value and the last value, you'll
And then
go through half the list because
yeah.
if you hit the middle swaps.
Yeah. So basically, you come from both ends, right? So start from the two ends and swap, and then go to next two and swap, and next two and swap, and basically we meet at the middle, and by that time it's reversed, right? So we can do, we can improve pretty much, we can improve the speed by half, like, you know, like like we can double the speed, and also it would work in place, right? So will not need to return a new list, right? So it will actually work in place if we do so. Okay, but there is another way to, well, without, so I would say this, that's the most efficient function. But storage wise, we can, you know, still do a full length for loop and then still use it in place. How do we do that? Let's do that one first. Maybe, you know, I'll only tell you, but let's do the other way now, because to save time. Basically, you, there are two functions, right? So you pop, right? You pop the one that you want to insert. Basically, you pop and insert, right? You you start off with to pop the last one and insert at the beginning, and then you pop the um, um, wait a second, you, sorry, you pop the first one and insert it at the end, then you pop the second sorry, you pop again. So let's write that one. I'll actually implement that later. Okay, so it's, you know, method 2 to basically we have this, and then um, right, so we have that, and then we pop this one and then and put it in the back. Okay, so we'll get this. So come this 4. Okay, and then you pop again. So now it's the first item is this, right? So we have this now, right? And then pop again, and then you get actually this, so 8, you insert that at right here behind the first one, right here. Okay, right, and you can see that you are popping always the first element, right? So that means basically pop zeroth, 0th, and insert at in this case -1, right, to 1, and then here pop 0 again, -2, right? So this one, right, and then you can right, so this one is actually now 8 and 6 4, and basically so you'll get this and 8 right here. It's actually now reverse, right? So 0 then n minus 3. Okay, so so if you want to generalize now, this is term 1 2 3, right? So -1, -2, -3. Okay, so right, so pop the 0th, and then a general way is basically, you know, pop 0th and insert it at negative ith element. Okay, so this one also work in place, right? So you're changing the your current list. Okay, but I'll add this code later. Okay, let's work on the 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 understand of the speed improvement. Okay, so right, so basically it's a swapping uh, thing, right? So you swap ends, and then likewise you move to the center. Okay, so basically say this one start off with this, right? So swap 4 and 10, right? Right. So basically, right, I'm gonna say swap right, sorry, left and right. Okay. All right. So we'll get basically this. So 10 and 4. Okay. Now we have this, right? So right, swap and we'll get and then 8 and 6, right? So we'll get 8 and 6, 8 and 6. Okay. So that means swapped next left and right and next right. Next right. So what is next left? We need to increment left by 1, right? So that means, okay, so right. So this is going to be a while loop. Why this is going to be a while loop? Because we need to grab the center to where to stop, right? So this is going to be a while loop, and then basically the moment left crosses right is the condition, and then that's at that moment we're going to stop. Okay. So 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 basically we need to increment left by 1 and decrement right by 1. So I would say uh, increment left by 1 and decrement left by 1. Okay. So let's write a plan for this. Okay. So I would say plan 3. Okay. So this is okay, plan 1. All right. So so we still input. Okay. Step 2. So we need to initialize left and right, right? So left is 0. What should be the right? The length of the list, right? So len, so length of input list. All right, 4. So now it's a while loop, right? While, what should be the while loop condition? So we need to figure out the crossing, right? So we are going ends like swap them, and then likewise we are going to come to the converge to the center, right? So less than, we are going to update both left and right. So it's actually while left is less than right. That should be the one. Okay. So left is less than right. Okay. So 4.1. So we need to basically swap, right? Swap swap left element right index left element with index right element. And what should be the next one? 4.2. Well, so if in this form it's actually infinite loop, right? So we need to update both left and right. Right? So increment and left by 1. So we're gonna go towards right from the left, right? So we need to increment left by 1. So 4.2, 4.3 decrement, right? Right by 1. So basically we are coming from right end towards left. Okay, that's it. No need to return anything because this is in place. Okay. All right, so how do we swap encoding? Swap two things, exchange two things in coding. Yeah, right. Otherwise, you just cannot reassign values, right? You'll need a temporary variable, so we'll create that. Okay. All right. So let's write the code of this one. So I'm gonna take this is 2, and it doesn't returns, right? So reverses the input list. Okay. All right. So so left is 0, so we need to assign left 0, right equals the length of input list. Okay. And then while, right, while left less than right. So basically, so left is here, right is here, we swap and then go to next pair, swap and go to next pair and swap and likewise. So that's what we're gonna do. Okay. So so swap, so we need to create a temporary variable. So temp. Okay. So let's say input list left. So now we can assign, right? So input list left equals input list right, and input list right equals temp. Okay. This is how you swap, guys. Okay. Just temp. Okay. And then we increment right and left 1 by 1. Okay. So left equals plus equal 1 and right minus equal 1. Okay. And that's it. Okay. So let's try this one on this. Oh, maybe I should call it right here. That's error. Okay, what is it? Index error, list index out of range. I think it's because, yeah, we are going above the range. Should be, yeah, length. Oh, this should be length minus 1, I think. Okay, yeah, okay. All right, so now I call the function. So I need, guys, what kind of function is this in terms of return value? That's a technical term we learned. What's the name? Non-fruitful function, right? Doesn't return anything. So we also call them modifiers as well. They modify the list. They doesn't return anything. So this is a non-fruitful function. This one is a fruitful function. Sorry. This one is a fruitful function because it's returning something. This one doesn't return anything, so we call it non-fruitful function. Or in this case, you can also call it a modifier. Okay, so right. So to see now we are doing it in place, right? So we are changing input list. So to see the result, we will have to print the original list, the input list. We are reversing this one. There's no output list. Okay. So it's a moment of truth. Okay, what happened? It didn't actually. Well, reversed. Yeah. You're fine. So to make it, I'm gonna print the original list over here. So print. All right. So this should print the reverse one earlier. We'll see. Yeah, there you go. All right. So see that we are starting off with this one and getting this. Okay. So it's a reverse list. Okay. So let's quickly go over the questions. Write a Boolean expression you use in your code. Boolean expression used in your code. This one, right? That's the Boolean expression. Okay. Well, if you didn't use this function, your Boolean expression is there's one more over here, guys. Okay, this is also a Boolean expression. Okay, so you are checking equality. Okay, that's also a Boolean expression. Say you didn't use a while loop in there, so then this is your answer. Write two punctuator type tokens you use in your code. Punctuator type tokens, two of them. Yeah, this one is a punctuator, right? Quotation, triple quotation, and also this one. Yeah, and then colon also, right? Colon right here, also a punctuator. So I'd say we have three right here, right? Three punctuator type tokens. Okay. Write an operator type token you use and the respect to operands in your code. There are several, right? So if you use, for example, if you use plus equals, this one, right? So what are the two operands? Yeah, left and one. And if you use this one, these are the two operands, right? Left and right. Okay. Write a method of a module or class you used and the respect to inputs to it if there are any in your code. So we use a lot of methods from list class, right? So if you take this one, right, append, then well, this is the parameter, input parameter we use. The append is the method, right? So sometimes we don't have inputs, so in that case you are fine. I didn't we didn't use such a function though. Okay. Write a formal and the respect to actual parameter of a function you wrote in your code. So the formal parameter is in the definition, right? This is a formal parameter, and this is a formal parameter, and in the call, you can see, like, again, this is the formal parameter. Okay, the actual parameter. Sorry, the argument. Okay. All right. Any question on this one?
Can you repeat number 4? It was the
Yeah.
method, which was
Write a method of a module class you use, right? Is that on?
yeah. I just wanted to like
Okay.
understand it.
So we use for we use actually the right here. So not right here. Okay, right here we use append method from list class. So the input to append method is in this case this one. That's the input parameter to append method. Okay. Yeah, and then I think that's about it. Yeah. But if you yeah, if you use the other function which I have to implement over here, you will use both pop and insert. Okay. All right. All right, guys. So let's go over this one. So so we were over here. We did actually we stopped right here. The scope of a variable, and we watched a video already, right? It's a really good one. I highly recommend watching it again if you had doubts, guys. Okay. So what I'm going to do is I'm going to take this code and let me try to this one. Actually, Google logged me off, guys. So let's see this one. See that? See if I remember the password. Yeah, it went through. Okay. All right. All right. Code. So text. So this is my code. I just copy pasted some. Okay. And instead of inputting, I'm going to just set the value. Let's say 30, and here it's 40. Okay. Okay. All right, so the total number of inches is 400, right? Okay. So if I run this code, so I get answer. So what the point I want to make is this. If I try to access this variable, print, see, I have defined it over here. I have defined this variable over here. But I'm trying to access it over here, I'll get a name error. Why is that? And it's saying that it's not defined, but it's defined over here inside my function. Why?
Because that's a different instance of photo emissions. It's not the same. If it's inside the function, creates its own variable total inches
Yeah.
that disappears once
So
it
basically, yeah, total inches there is local to the function, right? The scope of total inches is local. So that variable is only visible within function. So it's not visible to outside. So we call it actually the scope, and this is really important to understand, right? So it's actually a design feature across languages, not just Python. So pretty much every programming languages, the idea of scope exists. Okay, so basically, it's a strategic way to create and then allow users to create variables with different scope so that basically you can use the same name somewhere else as well. Okay, so basically what happened here is that, so this scope, this is the main program, and we call it the global scope, and then I define my variable within the local scope, which is inside my function. So this set of variables only visible to this function. So if I try to now print, right, if I print, then it will not complain. If I print total inches over here, right, it'll actually print that value, right? So oh, total inches. So it should be, why it didn't print?
you're calling your function after you try.
Oh yeah, sorry. Yeah, so that's why. Thanks. So I'm gonna do this. Okay, I'll still get the thing, but I'll actually print that. See that right here, 400, right? So basically, I have visible this variable is visible inside the function. So actually, I printed that value, right? Okay. So we call this the scope, and then this total inches variable, it's actually, we say, belong to the scope of that function. So we call that the local scope. Okay, and then the main program, we the variables defined inside the main program, it's actually called the global scope, and then they are basically visible to entire function. Okay, so let me ask this question: if I remove these two, would I still be able to run this code? If I remove these two, why not?
Because then you are trying to reference variables that have not been initialized.
So the thing is this, right? So we can try this one out. But these, you can see that these two variables, feet and inches, they are global, right? So global variables, the functions basically have visibility to entire global scope, right? So let me try. Probably because of it's down below, will not be able to run, right? So let's see if that works or not. All right, yeah. So it's actually well, we didn't have to pass this. So let's try now. Okay, it still ran, right? Because it's, they are defined over here, and call is down here. So when you see the call, you go to that. So that means you code already see the two variables, right? So they are global, right? These two variables are global, so you don't have to pass, you have access to them. But still, I usually do not recommend doing so. So because then you kind of ruin the idea of writing function, right? The input is now gone. So it's that idea is kind of the idea of the abstraction kind of ruined there, right? So even if the variables are global, and basically anyone recommends passing them as parameters to your function. Okay, so but I wanted to show you guys, because these are global variables defined before the call, right? So you still have access to them. Okay, but if I call it above, we may not be able to access, okay, run the code. Okay, all right. So let's continue. So we were already talking about this one. So there's a way to, right? So and then if we run this code, so let me run this code, and I will get actually so we'll get not applicable. Okay. Oh, I don't need to. I'm gonna. Well, that's fine. 40. I still get NA, right? So, right. So basically, I am printing employee name, right? Employee name is, I'm setting it over here, but I'm not returning, right? So basically, when I print NA, it's basically the visible scope of that variable is NA, right? So set the value NA, so I get that one. So how, the one way to fix this actually right here, right? So we use global statement. So it's a statement, okay, right? So we use global variable, global statement. See that over here. So this is saying basically set the employee name as global so that I can now use the value. Okay. So so if I try this one, well, I think let me see. Oh, I only need to remove the last two lines. Sorry. All right. So if I run this, let's say Jill. So I got the name Jill, right? So how many statements so far we learned in the class? Shall we count from the very beginning? What is the first statement type we learned in the class? First statement type. We are learning a new statement today, which is global statement. First one. Uh, there's no print statements. So print is a function. So function calls are expressions. We say colloquially, right? We say sometimes print statement because other languages they are statements. Printing because printing is a calling a function in Python, right? So we casually say print statement, but it's not actually. So it's actually a function call. So you said which one is the first?
The triangle is we use that we so basically the statement and function are the same. Are they the same or not? That's what it says.
No. So the first statement type we learned in the class.
Print is a statement.
No, it's actually a function. Print is a function. Yeah. First statement type we learned. Come on, guys.
Or the function definition. That's not statement. I don't remember. I know it's not. But
This is terminology. What is it?
return statement.
That's the second we learned. Or third we learned. That's the third we learned in the class. What's the first one? Assignment statement. Okay. All right. You guys knew it, right? Okay. So then we learned the import statement. Second. Third one is the return statement. What is the fourth? Not this. No, length is a function. We learn one more statement before this one. The pass statement. PASS. So this is the fifth, the global statement. Okay, I think there are 8. I think we'll stop right here. No more. We're not gonna learn any more statement types in this class. But I think there are 8. You can actually see it in the documentation. Okay. So all right. So using global statement, you can actually access or change. Sorry, not access. Change a global variable inside the function. Okay. So that's what we did right here.
You can't access.
You can access and even change a value of a global variable inside the function. So that's what we did right here. Right.
I thought you were saying you cannot.
No, you can access. All right. So we're gonna learn this topic today, right? So kind of a little bit ahead of the time. Okay, so I just published it. It's in module 12. Okay, so refresh your module view. So this is a little bit ahead of time. So you have actually time to do this, guys. Okay, so this one is it's actually feed to steps converter, which is simple. You have done something similar, I think, right? But the rest is little bit tricky. So I have given a full instruction on how to do this. So take a look at this section in which basically you can see how actually how you can take a sequence of numbers like this through input and then to make a list of those numbers. Okay, and that code have an example on that, so you have to refer that on how to do it, right? So you basically need to split this one, right, into these numbers based on the space as the delimiter, which is the default. Okay, and that's one input. This you input this, and the next is input is just a number, which is a number of feet per step, right? And then basically you convert feet to step. For example, that is 2 here, so that means 10 divided by 2 gives you 5 likewise, right? But the default you have to set in your function, default is 2.5, right? So that means for the last one, you have to actually do it for the default, which is this instruction. Okay, so yeah, then that's it. Basically you return this one. Take a look at the template code given to you, right? So you use input function twice. Okay, and then you call your function for the entire length of that list, right? That you get your input, first input, right? And then the call again for with the default value for the last item of that list. And that's it. That's all you have to do. Okay, for this one. So unfortunately, I'm still working on the programming assignment, guys, of that module, but I should be able to publish this one today or tomorrow the most. Okay, so this one, but I'm going to show you it's the code check that I am actually handling right now, but the problem statement is same. So it's basically you're going to end up writing 4 functions. One is for calculating the rhombus area and the other one for calculating the perimeter, and then 2 more functions that uses this function to calculate the stadium area and stadium perimeter. And this is the stadium right here. It's the stadium, and this is the rhombus. So there's formula. There are 2 formulas for rhombus. One is for A, it's the perimeter, and then the rhombus area. And and then you'll basically implement these 2 in 2 functions, and then to return the area and perimeter of the stadium, you'll write 2 more functions. Okay, so right, so that's the programming assignment, and then I'm gonna give you guys some template code, and then you will do it in code check. Okay, all right. So so that's the functions, sorry, things available in functions module, function part 2. So let's go back to our lesson here. So we're gonna start our lesson on internet today. All right, so this is a project started by US Department of Defense in 60s. Okay, and by the 80s, National Foundation, NSF actually funded further improvement. Okay, and I think in the late 80s it became the internet, right? Right. So and then the information we send through with something called packet, right? So it has the data and then the location information, destination information, those things inside, and then we create packets, and then a stream of packets travel through either wire or wireless. Okay, so there are several protocols behind this, and then the entity behind is, I think, the World Wide Web Consortium, the WWW. So it's a group of experts who time to time come together and then revise these protocols and improvements, right? So one popular protocol is the Internet Protocol, which we call in short IP, right? And then there's another one associated with, we call the TCP/IP, Transmission Control Protocol. So together we call TCP/IP. Okay. So to access an internet, we all know we usually have a router or a modem, right? And that's usually provided by the internet service provider like AT&T, Comcast, and there are several, and now the satellite internet from Starlink, right? So the routers like Cisco, and then I think Broadcom, they also make routers, I think. They make routers, which is a specialized computer, by the way, okay, for routing purposes. Okay. All right, IP address. This is the structure of an IP address. Okay, so there are, so for the first, the current version, not the current version though, but current version is IP address version 6. But the that's the newest one. But the most recent, like earlier one, is IP Internet Protocol version 4, which uses 32-bit. Okay, so it's grouped into 4 segments. So 4-byte segment. See that 8 bits here, which is 1 byte, and then another 8 bit, another 8 bit, another 8 bit. So all together it's 32 bit. Okay, 32 bit. So there are 4 segments. So with this IP address format, how many different IP addresses can the internet have? 32 bit. How many combinations of IP addresses? Remember, we encountered this before in week 2 actually, right? When we were talking about binary numbers. How many combinations of IP addresses? Yes. What is the value? 2.63130 times 10 to the 35th power. Okay, so then in the power of 2, what is the number? In the power of 2? 2 to the 32, right? To the 32, right? So basically, so the number of IP addresses is 2 to the 32, which is close to 4 gigabytes, 4 giga. I think there's that numbers over here. They have mentioned that 4 billion. Sorry, 4 billion. Okay, so version 4 is 4 billion, and then right now the current version, basically we ran out. There are more than 4 billion websites right now. Okay, so it means we need more than 4 billion IP addresses, right? So we change to IPv version 6, which is 128-bit address, representing 2 to the 128 different addresses. So that's actually this number. So 360 trillion addresses. It's a lot. So for a foreseeable future, we will not exceed that number. Okay, so that's the version 6. All right. So there are two types of IP addresses. One is static IP address and the other is dynamic IP addresses. Usually your home desktop, laptop, phone, your computer, all of get a dynamic IP address. Okay. One purpose is basically when you reboot your device, you usually get a new IP address. And if you reboot your home router, you'll get a new IP address. So it's dynamic, it's changing, right? Why changing that? Why use dynamic address for the client basically? It's secure, right? Because it's not always one. So hackers, though hackers can get access, it may change next time, right? So they cannot keep track of it, right? So it's hard for them. So it's a security feature. It's a dynamic IP address. So for the clients, right, usually the users of the internet, you get a dynamic IP address. Usually that's set by the router. Actually, router does it. Okay. So the GitHub, this is the next room. GitHub one, yeah, 301B. Okay, all right. Sorry.
You should put a sign on the doors like no GitHub in here.
So okay, so why then? Why the utility? What the utility of static IP address then? Okay, so usage of dynamic IP address is clear. Why we need static IP address? Yeah, right. So then, yeah. So basically, let's say you want to access CNN. CNN should have a single IP address, right? All the time. Otherwise, browser gonna have a hard time finding it because it's now changed, right? So it need to be static IP address. So that means if you want to create a website for yourself or for a company or any entity which is commercial or under any other purpose, like the server side for the internet need to have static IP addresses so that the domain name can register that name and then can have access, can give that name always when there's a lookup come up, right? So that's the static IP address. Okay. All right. So I'm gonna skip this one, guys. Home networking. You guys can read it. Maybe it's outdated as well, a little bit. Okay. Cellular networks. I'm going to skip. Come back to this one later, Thursday. Okay. So web basic also I'm gonna come back to. Let me see that. Oh, this actually we can discuss this topic. All right. So in the web, so there are web pages, right? There are other things we do with the web, right? So for example, we send files over network. We call file transfer protocol, right? So the web pages we usually see, we call it the HTTP protocol, right? So in short, basically we call it hypertext transfer protocol. Okay. So that's the short form HTTP. It's basically the next level of internet protocol. So if you want to list them down, right? So HTTP is the next protocol. Okay. So HTML is the way we access that protocol. It's in short, basically, it's a hypertext markup language, HTML, right? So you use HTML language, which is a programming language, you can say. It's very simple one. It's a markup language. So there are tags, we call them markup, and we use that to express different features. So hypertext markup language, HTML, to use create web pages. Okay. So the program known as the browser is basically to view and access and HTML files. Okay, it's the browser. It's a type of a virtual machine actually. So these days, all modern browsers are virtual machine for JavaScript programming language. Okay, so yeah, so those, so there are three parts, which is one is JavaScript, and then cascading style sheets CSS, and the HTML together usually make up the web page, actually make up a web page. Okay, all right. So World Wide Web is the www. That's many website actually start with that. Okay. Domain name and URLs. Which this is the topic that we need for today's discussion actually. So there's a separate entity called Internet Consortium for Assigned Names and Numbers. So um, they are, that's the entity actually, the um, they manage domain name system. Okay, so basically every web server has the address, this IP address, right? And you can see that it's bunch of numbers, right? So humans basically, it's, you know, it's you know, have a hard time remembering numbers, right? So we are more capable of remembering patterns and names kind of things, right? So basically, to make it easier, so there's this feature called, it's similar to phone book, right? Phone book has a name and number, right? It's same here. So you have the web, like English web address, and then the respect to IP address. So that system is called domain name system, DNS, or domain name server, DNS, right? So so basically, so the thing is, to register a website, you first need to have a static um, um, web web address. So what you do is, you basically go to the domain registrar, which is a company, like one famous one is GoDaddy.com, right? And then tell them, hey, I have this website, this is my name, please give me a address for that. So that process is called domain registering. Okay, so and once you register, it actually takes like $10 per year to register a domain, right? And then you can basically, that IP address is now reserved for that domain. Okay, and you can then later use that IP address, and then create a web content based on that. Okay, so this is this enabled a great business model, which you can actually upfront register a, you know, would be famous domain, and then you can later sell that. And for example, cars.com was sold for almost $1 billion, right? So if you have a good name, right, you better register it right now, so that, you know, that become money later, right? So insurance.com was a big sell like that. I forgot the I think 200 something million. Okay, so and there are even, you know, user groups like meetups, so get together and share ideas to create big, you know, would be popular domains, and they go ahead and register them, uh, you know, thinking that later on someone will demand, and then we can sell them, right? So yeah, but you cannot do this for existing one, right? I think that there's a different it's illegal, right? So for example, if Coca-Cola don't have a domain, you can now go and register coke.com. No, because Coke is registered already, so it's not allowed to create the new domain for that. They only they can do it. Okay. No, you can't. You can't. Okay. It's already registered, by the way, but if they haven't yet, you can, because it's a registered trademark, so there are some laws behind that. Okay, I think if it is not a registered trademark, you can, like for example, let's say um, some restaurant is becoming popular, but they don't have a registered name yet, so someone can actually do that. Yeah. All right. So domain name has a hierarchy. Usually the name what we see, like like CNN is the second level domain, and the first level domain is the one that before that, right? For example, cnn.com. .com is the first level domain. Second level is CNN. Okay. And if you have others, then you can have others to the front as well. We call them third and fourth likewise. Okay. Remember, the levels of domain separated by a dot, not slash. Okay. Why do you separate with slash? Yeah, so basically it's pages, right? So sub pages or sub folders, you can use slash actually. Okay. So so top down structure of domain is basically from right to left, not left to right. Okay. So usual thing are left to right in computer, right? But this one is right to left. So that means the first level domain is the first one you see, like .com or .edu, right? And then the second level, which is the website name, and then so on and so forth, right? But this feature sometimes scammers used to fish people using this. For example, this one, right? So let me quickly play this one, right? So the website you see is amazon.amazon.com.aaa.cc, right? But this is actually bogus website, and people may wrongfully think it's actually belong to amazon.com, but it's actually belong to aa.ccz website, which could be for criminal use, right? So right, and you can see that that's the first, second level domain, which is the website name, right? So and then the rest of the parts are third and fourth levels, right? So the subcomputer systems of this one, right? Okay, so this is not amazon.com. So probably people will, they can set up entire homepage of Amazon into this, and then when you enter password, they actually now steal your password and then username, right? So that's actually a phishing. So we call that actually cyber squatting. Is that some? No, the cyber squatting is actually for like the reason I earlier explained, right? So registering domain name for already existing entity, right? That's cyber squatting. All right. So URLs, right? So I think we can. Oh, I'm gonna stop right here, guys. I'm gonna come back to this one on Thursday. URLs. So let's do the problem today, which is this one. Sorry, this one. Domain name. I just published it in module 12. Okay. So basically, given a URL like website address, you need to find um, the second level domain, which is the website name. Okay, so URL come in as in this form. Start with HTTP or HTTPS, and then so forth. Okay. All right. For this one, actually, um, the street address problem is a good match actually.